everyone. In today's video, we are going to cover identifying functions. Our learning target for today is I can determine whether a relation is a function. First, looking at identifying functions. A function is a rule that assigns each input, or x value, exactly one output, or y value. Functions occur when every x value is associated with exactly one y value. So what that means is the x's cannot repeat while the y's can repeat. So if you have a function, you would have all x values be different, where the y values could be the same, but they don't have to be. Looking at tables and ordered pairs, to test whether or not a table or set of ordered pairs represents a function, look to see if each input, again, the x values, has exactly one output, or y values. If there's more than one x value, then you cannot have a function. And then from graphs, if a graph represents a function, it should be able to pass what's called a vertical line test. This means that any vertical line drawn on the graph should intersect the graph at exactly one point. Now let's try to determine whether or not the following representations are functions and explain our thinking. So looking at number one, we have a table with x values and y values. Remember, we have functions if each x value goes to exactly one y value. So if I don't have any x's repeat, then I would have a function. Notice in number one, I have -2, -1, 0, 1, and 2. None of the x values repeat, so this would be a function because each input goes to exactly one output. I do have y's repeat, 7 and 7, and then 1 and 1. That's okay. I can have y's repeat. I cannot have x's repeat. Looking at number two, I have x values of -2, 3, -4, -2, and 0. Notice here I have -2 and -2. I have x values repeat, therefore this is not a function. X's cannot repeat for something to be a function. Looking at number three, I have a graph. Now this is where my vertical line comes in. So what I'm going to do is I'm going to have a vertical line, and then I'm going to pass it through my graph from side to side. Notice when I pass it through my graph, it's not touching any 2 points at the same exact time. This would tell me that this is a function because no x values repeat. So 3 is a function, yes. Looking at number four, now when I pass my vertical line through number four, notice here when I pass it through, here it's touching this line at 3 different points. It's touching it here, it's touching it here, it's touching it here. These would be 3 of the same exact x values, making this not a function. So no, because the x's repeat. And then looking at number 5, we have a straight line. When I pass through my vertical line, I can see that I don't have any 2 points touching the vertical line at the same time. Therefore, this is a function because no x values repeat. We just looked at how to identify functions from tables and graphs, and now we'll look at how to identify functions from equations. So an equation represents a function if every input x will result in only one output y. We can substitute various input values to see if an equation represents a function. Looking at 6, 7, and 8, we have 3 different equations. We want y solved for in terms of x. This will make our lives the easiest. What that means is I want y by itself. Notice in number 6, I have y equals x squared, therefore y is by itself. So now I could plug in various input values to see what my output values would be. So I want to range, so I'm going to go some negative and some positive. So I'll plug in -2, -1, 0, 1, and 2. If I plug in -2 for x, it'd be -2 times -2, which would give me an output value of 4. If I plug in -1, -1 times -1 is +1, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. Now I can give kind of a rough sketch of what a graph would look like. So this would actually be what's called a parabola. And parabolas are functions, I can tell, because this would pass the vertical line test. So this is yes. Every input has exactly one output. So y equals x squared is a function. Whenever I have an x squared by itself, that will give me a function. Now looking at number 7, I have y squared equals x. Again, I want to solve it in terms of y, which means I want y by itself. So I need to get rid of this exponent of 2. In order to get rid of this exponent, I would take the square root. Therefore, I would have y is equal to the square root of x. Now, I know that whenever I took the square root of something, it's actually two values. So let's say, for instance, I plug in x is equal to 4. So y is equal to the square root of 4. Actually, this is plus or minus 2, because if I take 2 squared, that's 4. But if I also take negative 2 squared, negative 2 times negative 2 is also 4. When you take the square root of something, that gives you two values. Seeing as I have one input that goes to two different outputs, this is not a function. This is null. So whenever I have y squared will not give me a function. Looking at number 8, I'd have x squared plus y squared is equal to 25. Notice here, again, I have a y squared. Just like number 7, when I had a y squared, this would not be a function because I will have inputs go to multiple outputs. So the one input will go to two different outputs. X squared plus y squared equals 25 is actually the equation of a circle. Circles are not functions. In today's lesson, we learned a function is a rule that assigns each input exactly one output. X's can't repeat. To identify a function from a table, look to see if the x values repeat. To identify a function from a graph, see if it passes a vertical line test. And to identify a function from an equation, test x values to see if any will repeat. That's a wrap on today's video. We'll see you in the next one.